Hello there, welcome to A-Level Maths PO Paper 2 of June 2023. Here we're looking at question 14. Show that this equation here may be written as sine 2 theta times this cos squared function here, and where a and b and c are constants to be found. So the first thing I'm going to do is I'm just going to start by expanding all of these brackets. So let's expand the first one. 16 tan theta cos theta, add 46 tan theta sine squared theta equals 8 sine 2 theta, add 8 sine 2 theta tan squared theta. Alright then, okay, so what I think we're going to do first is we're going to multiply everything by, let's just simplify these individual bits. So I think tan can be written as sine over cos. So if we've got tan multiplied by a cos, then that just ends up as a normal sine. With the 46, we're going to have, if we turn that into a sine over cos, we're going to have 46 sine cubed over cos theta equals 8 sine 2 theta. Do I want to expand that? I don't think so, because I've got 2 theta in my answer, so I'm not going to expand that. And then plus, I will expand the tan squared, so it's going to become 8 sine 2 theta times sine squared theta over cos squared theta. Right, okay, let's get rid of all these fractions and multiply everything by cos squared. So I'm going to get 16 sine theta cos squared theta, add 46 sine cubed theta. We've got over cos theta, but I'm multiplying by cos squared theta, multiplied by cos squared theta. So that's going to give me cos theta equals 8 sine 2 theta cos squared theta, and then plus 8 sine 2 theta times sine squared theta. Okay, so I need to now try and make as many sine 2 thetas as I can. Every term in our equation should have sine 2 theta in it, and everything should then, apart from that, be in terms of cos. So in the first expression here, I'm going to take out 2 from the 16 sine and a cos to leave me with 8. I'll have one of these coses left over, and then I'll have a sine 2 theta from 2 sine theta cos theta. I'm going to do something very similar with a sine theta, a cos theta, and a 2 here to leave me with 23 sine squared theta sine 2 theta equals, I've already got the sine 2 theta in this one, and I've already got the sine 2 theta in this one, so 8 sine 2 theta times sine squared. Okay, let's move everything onto the left-hand side, and I've got this term here and this term here that can simplify with each other. So I'm going to move everything onto the left-hand side now, so it's going to become 8, reorder things slightly as well, 8 sine 2 theta cos theta, add, when we take away this term and this term, we're going to get 15 sine 2 theta sine squared theta. And then we're going to also subtract this term to the side, 8 sine 2 theta cos squared theta. And that will all equal 0. Now we can factorize out sine 2 theta, sine 2 theta, open brackets, 8 cos theta, plus 15 sine squared. Now immediately, because I know that everything inside my brackets has to be either cos or a number, I'm going to turn the sine squared into 1 minus cos squared. And then minus 8 cos squared theta equals 0. Okay, that's pretty good. We're pretty nearly there now. So sine 2 theta, open brackets, 8 cos theta, and then we're going to have plus 15 minus 15 cos squared minus another 8 cos squared, so that would be minus 23 cos squared theta equals 0. So there we are, excellent. So we've therefore got an expression where A is minus 23, B is 8, and C is 15. And you could have effectively moved it to the other side and had all these constants with a plot with a plus 23, minus 8, and minus 15 as well. Right, then let's now move on to part B then. So we need to now solve this equation between 360 to 540, where we have this equation here, but I've put our rearranged form up on the screen there. So what we're now going to do is we're going to solve each of these two separate equations between 360 to 540. So first of all, start off with sine 2x equals 0, and then we're going to move on to 8 cos x plus 15 minus 23 cos squared x equals 0. So first of all, we need to think about when our sine graph is equal to 0, and because our range has doubled here, it's now between 720 to 180 to 1080. Okay, so let's now visualize our graph in that region. So we've got sine graph up to 360, sine graph up to 720, so 2x equals 720. The next solution is going to be 900, so that's add 180, and add another 180 is 1080. So this marker here was at 720, this point here was at 900, and this point here was at 1080. And then we half all of these answers to get 360, 450, and 540. Okay, I'll come back to that in a second. What we're now going to move on to is this section here. So we plug this straight into your quadratic solver, and we get cos x equals minus 15 over 23. Let's double check that on the calculator. Minus 15 over 23. Cos minus 1, the answer. So cos minus 1 of 15 minus 15 over 23. That's the only viable solution. There's another solution that's outside minus 1 to 1. And we get 130.7. But that's not in our range of answers, so let's look at the cos graph and how we would find a solution inside the range. So that's the cos graph up to 360. Now the cos graph down to 540 would be at this point here. For a solution of minus 15 over 23, the graph will intersect at this point here, but we are interested in this intersection point here. And to get that intersection point from 130.7, we'll add 360 onto our answer. So add 360 to answer, and we get 491 degrees. So there we are. Now, what we have to do now is we have to check that our answers go back into this equation, the original equation, and it doesn't give you a math error. So particularly the tan we're going to have issues with. Sine and cos will always be fine, sine 2 theta will always be fine, but tan, remember, does sometimes give us issues because it could equal 0, because it could be an asymptote at that point. So if we type in tan of 360, that gives us 0, okay, that's absolutely fine. If we type in tan of 450, then that gives us a math error. So we have to now delete this solution here. In fact, I've just seen also at the top, it says that x cannot equal 450. Typing in tan of 540 also gives you a 0, so then that is absolutely fine. So our three solutions here are 360, 540, and 491 would have been absolutely fine anyway. That's not going to break tan at all. So there we are, that's the answer to question 14 with a total of 7 marks. Let's now move on to question 15.